In this video, we'll be going over motion graphs, velocity, acceleration, and energy. So let's discuss with what is physics actually doing. So we know in physics, right, we are describing how things change and why they change. So in physics, everything essentially comes down to motion, forces, and energy. And in motion, we measure in motion, we have position. What is position? It's where something is. So think X. That's your location on a number line. So think like X is equal to 0 meters. You're at the origin. X equals to positive 5 meters, you're going to be 5 meters right. And position is dependent on how you create your coordinate axes, right? So this, we can define positive y to be up, positive x to be down, negative y to be down, positive x to be this to the right, and negative x to be the left, right? And so that means x is equal to negative 3 meters. That would be your 3 meters to the left. So, yes. Now, what does position not tell you? There's a lot of things that people get wrong about position. So, position does not tell you how fast you're moving, whether you're speeding up, or whether you'll stop. Right? It's just where you are, right? Now, from position, we can create a graph. So, in our graphs, we can create X versus T. So a position versus time graph. This is your horizontal, it's that, and then your vertical axis. You have X and T. So each point, a point is where is this object in time? And the slope of this type of graph is going to be the change in position, or delta x, and the change in time. Change in position over the change in time. And the slope is actually going to equal to velocity. Now, let's talk about what each of these shapes mean. So, of a graph, a position time graph, you can have multiple types of graphs. You can have a straight line. Now, let's break down what this means. And you can have a curved line. So what do each of these mean? Well, your straight line, this means that you have the same slope everywhere, because it's changing at a constant rate everywhere, because slope is the change in these positions. It's going to be the same rate of change. So this means that your velocity is constant. Velocity is equal to slope. And that means that you have no speeding up, no slowing down. But if you have a curved position time graph, that means that some of these are not true. So for your curve, that means you have a different slope everywhere. It's changing. Your velocity, therefore, also changes. And that means that, yes, speeding up, yes, slowing down. That means acceleration exists. Now that we have covered position versus time graphs, we can move on to velocity versus time graphs. Another very important physics concept that you have to know. Okay. So for velocity versus time, before we break into that, let's talk about what velocity is. Now, velocity is how fast and which direction. So, to analyze a sign, if you have a positive velocity, that means you're moving right. We can just say negative velocity, moving left. And this is based on the convention, again, that we have used here. So before you even analyze all of that stuff, you have to have your coordinate axes. And these are the coordinate axes we'll be using. So this is our definition. Unless you define your coordinate axes to be something different than the standard coordinate system here, then your velocity and your position and your acceleration will all follow the same rules. So let's start off with let's continue with some misconceptions. Velocity is not how fast. That's speed. It's not acceleration. And it's not a force. Now for velocity versus time, your horizontal is your horizontal axis. V is your vertical axis. And 1 point, it represents how fast and which direction at this time. So what does the slope of this type of graph represent? The slope is the change in velocity over the change in time. Now, we can draw these velocity time graphs, VT. Now, if you have a straight line, that's a constant acceleration. And if you have a flat line, you have zero acceleration. Flat line, zero acceleration. Now, let's move on to what the definition of acceleration is. Acceleration. Now, this is the culminating thing. Acceleration is the change in velocity. So we're stacking these concepts. Now, acceleration does not mean necessarily speeding up, moving forward, or growing faster, which are things that people always equate. There's actually rules for this. So let's make some room. Let's make a little room. So we can break this down into situations. So if we are moving right and you're speeding up, we can look at the velocity and compare it to the acceleration. So this means if you're moving right, that means that you're moving in the positive direction. So velocity, think about the direction because it's a vector. So if it's moving right, you have a positive velocity. And that means if you're speeding up, you also have a positive acceleration. Now, if you're moving right and you're slowing down, well, if you're moving right, you're still going in the positive direction, right? And if you're slowing down, though, that means your change in velocity is the change in your velocity is just less because it's not keeping up with the constant change. So that means you're decelerating. Acceleration is going to be negative. Now, what if you're moving left and you're speeding up? Well, if that's the case, you're moving left, you're going in the negative direction. So and your acceleration is going to be negative. So if you're moving left and you're slowing down, your velocity is going to be negative because you're moving left and you're slowing down, your acceleration is going to be positive. And here might be the area that you're kind of getting confused in. This kind of seems like off, right? Well, we're gonna touch on that. But first, let's write. So again, you're moving right, and then something is pushing you. So something pushing you further left. Here, you're moving right, but something like friction is pulling you left. That's why you're slowing down. And you're moving left, right? But something is pushing you even faster left, so it's helping you. And here in the last case, you're moving left, but something is pulling you toward the right, acting as a brake. Something that a lot of physics students think is that they think that a negative acceleration equals slowing down, and that's wrong. You can think of this as like if a car is already moving in the negative direction to the left and has a negative acceleration, it's actually gaining speed in the negative direction. So think of a car in reverse slamming on the gas. Like if it does that, it's getting faster, but its acceleration is negative. So you always want to look at the signs together. And so there's a signs rule. If they match, you're going faster. If they fight, then you're slowing down. You're just speeding up versus slowing down. So remember, positive velocity is right, negative velocity is left. Same sign versus opposite. So same sign means you have both positive, and you have both positive velocity and positive acceleration. And if you have negative velocity and positive acceleration, or positive acceleration and negative velocity, that is opposite. because they have to be traveling in the same direction. Now, continuing on with that, so basically your takeaway is that acceleration can oppose motion. So, why can the x-axis t graph look curved? Well, an example of this is like the object moves left, so that means that you have a negative velocity. And then if it's slowing down, then that means that velocity magnitude decreases. And if the acceleration is to the right, that means velocity becomes less negative. So this would be an example of if you had something like this. This is a downward flattening concave up curve. And if you have a velocity time graph that's like this, no, let's just do it like this. This means that your acceleration is constant. And this means that your acceleration is positive. And that means that your velocity changes at a constant rate. So, your rule is that if the x of t slope is steep, that means you have a large v. If x of t slope is equal to 0, your velocity is equal to 0.